right, yesterday we talked about 2 of the 4 periodic trends. The 2 that we talked about yesterday were atomic radius, or atomic size, and ionization energy. Atomic radius tells you how large the atom is. Ionization energy tells you how hard it is or how difficult it is to pull an electron off of that atom. That is something that occurs during bonding, which is going to be the first thing that we talk about after Christmas. So it's kind of an important idea of how hard is it to pull an electron off. That's what happens when atoms react with each other, when they bond with each other. So that is kind of a key idea. What we're going to do today is go over the last 2 periodic trends. And I believe they are out of order on your notes packet. So find the one that says electron affinity, because we're going to do that one next. If you have an affinity for something, that means that you like it. That's what that word means. Affinity means how much do you like that, or how much do you want that. So electron affinity is kind of like the opposite of ionization energy. Ionization energy tells you how hard is it to pull an electron off. Electron affinity tells you how badly does that atom want an extra electron added. Electron affinity is the energy that is released when an electron is added to an atom. That happens when you make an anion instead of a cation. Cations are positive. They happen when you lose electrons. That's what we talked about with ionization energy. When you make an anion, you have to add an electron to it. The ion then is negative. And instead of taking energy to pull that electron off, you get energy out when an electron is added. It's kind of like that opposite process. We can replicate that with magnets. If you have 2 magnets that are stuck together, it takes energy to pull them apart. They don't just fall apart by themselves. If you take 2 magnets that attract and you bring them close enough, you can feel that attraction, and then there is some energy released in the form of sound when they come together. Can you guys hear that? Wonderful special effects this morning, right? Ooh. Got a couple of smiles. Anyway, this little equation that's up here shows you kind of the simplified version of this process. So if you started with an atom and you added an electron to it, you would make an anion, that's a negative ion, and then there would be some energy released. The amount of energy released is the electron affinity. As you go down a column, so from top to bottom on the periodic table, electron affinity decreases. There's less energy released as you go from top to bottom. As you go across a period, left to right, electron affinity increases. So as you go from left to right, there is more energy released when you make an anion. The reasoning behind why this trend works the way it does has a lot to do with atomic size. As you move from left to right, or as you move from top to bottom, the nuclear charge increases. That's a fancy way of saying you're adding protons. We talked about this yesterday as you add protons from left to right. Also, as you move from left to right, the atomic radius decreases. So you add more protons left to right, the atom gets smaller left to right. A stronger nucleus and a smaller distance in between the protons and the electrons, the pluses and the minuses, means that you have more attractive force between those 2 things. Kind of like that magnets analogy. The stronger the magnets, the louder the click is going to be when they come together. If you have more attractive force, there's going to be more energy released when an electron is added. Last trend. This one's a little bit different. This is called electronegativity. Electronegativity is, again, it's important when we talk about bonding. It will help us decide what type of bond is being made. So that's something that we'll spend quite a bit of time with after Christmas. Electronegativity is the tendency of an atom to attract an electron when it is bonded to another atom. One thing that we'll learn after Christmas, or that you may have already learned in junior high, is that when atoms bond together, they can possibly share electrons. Electrons could switch from one atom to the other. There's a couple other little types of bonding that we'll talk about too. But electronegativity tells you when those two atoms are bonded together, which atom is pulling more on those electrons. It's almost like a tug of war. Those two atoms are almost like they're fighting over the electrons. If they both want the electrons, the trend of electronegativity can tell you which atom is winning that tug of war. It can tell you which atom the electrons are closer to. So, how does this trend work? Fluorine is the most electronegative element on the periodic table. And electronegativity is set up on an arbitrary scale. An arbitrary scale means that somebody picked a number to be the top of the scale, and that number was 4. So fluorine is the highest electronegativity, and its electronegativity has a value of 4. Somewhere along the line, somebody just picked that number. So this is going to be the highest. We're going to compare everything else to this. The electronegativities are listed on that periodic table that you have at the back of your notes packet. There's a teeny tiny little number. I think it's in the bottom right corner of those periodic tables. As you go down a column, so top to bottom on the periodic table, electronegativity decreases. As you go across a period from left to right, electronegativity increases. So why is that the case? Again, this trend is related to size. We've talked about 4 periodic trends between yesterday and today. One of them, the first one we did, was size. The other 3 are related to size or because of size. Smaller atoms hold their electrons closer to the nucleus. Again, it's that distance between the protons and the electrons, and how that changes the strength of the force, or the strength of the attraction. That means there's a stronger pull on the electrons because they're closer to the nucleus. So a smaller atom is going to be winning the tug of war in a bond with a larger atom. The smaller atom is going to have the electrons closer to it. One thing that I would add to the bottom of this page on your notes is a little chart. Sketch a small periodic table. It doesn't have to be perfect. Where is the biggest atom located? We're not doing the lanthanides and the actinides. We're just going to leave those off. Where is the biggest atom located? Which corner? You're close. Bottom left. This is francium, by the way. Bottom left. Atomic size increases down into the left. This is the one you have to memorize. You have to know that francium is the biggest element or the biggest atom, at least in the main section of the periodic table. Because if you can memorize this, you know the other 3. The other 3 are all opposite. The other 3 all increase up and to the right. So that would be ionization energy, that would be electron affinity, and that would be electronegativity. You have to memorize size. If you can remember which corner is the biggest, then you automatically know the other three trends because you know that they're opposite of size. Once you get this down, then we are done with our notes. And we'll finish up our labs, and we have a homework to do.